welcome everybody back to another episode of Trivial Objections. Once again, I'm your host, Jared. Today we've got some returning people who haven't been on in a while. We've got Daniel and Jacob back again for another episode. How are we doing, guys? Good?
Doing well.
It's been a while. We're going to try a new thing for this week. Little Saturday morning podcast. And the topic today is the future of space. Now, that's pretty deep, pretty broad. And I think we mentioned in previous podcasts that we've got some space experts or enthusiasts. Danny himself works in the space industry, and so you kind of deal with satellites and GPS technology. Is that correct?
Yeah, that's correct.
Okay, great. And then Jacob, you're just more interested in
Yeah,
in
I
like
read
the
a lot of
topic?
sci-fi. So,
Okay. So I wanted to go over a couple of topics that I was reading about. The first one being that recently this week, the Mars rover Curiosity, I believe it's called, NASA's rover that's been, roaming around Mars for I don't even know how long, has found the building blocks of life on Mars. And from what I've been reading, there's some debate on, was this just remnants of like past life on Mars, or is this like, you know, is Mars restarting? There's a lot of debate there. Do you guys have any insight? Have you read up on that? Do we know kind of where this is coming from?
Well, I mean, we know where it's coming from. It's coming from NASA. And it's an exciting process, and they haven't really decided their official stance on it. But basically, they just found some organic material and carbon material, which is what life's made out of. And it could either be remnants of life, it could be byproducts of life, or it could just be a byproduct of an inorganic process. And they're just trying to find some more information, more evidence on what could have put that there right now. Further investigations with the rover into the areas, things of that nature.
Okay, so there's this kind of like proves there's pretty good evidence that life existed on Mars at some point, and that this kind of further proves that. Am I understanding that right?
I'd say it's another good indication of life. I wouldn't say that it's pretty positive that there's life there. I mean, there's no doubt that there was flowing water, moving water on the planet. There are oceans, streams, and rivers. And then now we're finding carbon evidence. So it's starting to look better for the evidence of life, but I wouldn't say it's a for sure thing yet.
right, what they found is normally associated with life. Like, you would expect to find that if there was life, but also the stuff they found could be there if there even wasn't. So, but it does help the cause to see if there is, is life.
Okay, I was also seeing that like they're still trying to debate whether it was life that was or like this matter was like produced on the planet, or like it was brought in from like external factors, like maybe a meteorite or a comet or something like brought it here, or it was like I don't know, created here. I'm not sure if that's the right term. Is that what some of the debate is as well?
Some of it is always that, you can always try to decide if it was there originally or brought in, but I would just argue, what you're going to find on the planet, because even with Earth, like, did it originate on Earth or was it brought in by a meteorite? It really doesn't matter. It just matters that life existed on the planet, and if it did, it doesn't really matter how it got started.
Sure. Okay. Gotcha. So this will definitely give more momentum to the going to Mars argument, maybe, possibly, or is this kind of just an insignificant blip on that narrative?
A little bit of help and a little bit of hurt, I think. it'll definitely pique interest, and so more funding, and people will want to get there and find out, what else is there, looking for that smoking gun of life. But also, it might hinder human exploration because of the fear of contamination. If we do happen to find organic particles and we want to find more, if we went there, we'd be contaminating the planet with all of our materials, and which we may have already done with the rover. That's why whenever it dug down, it's sure that it wasn't a contamination issue. And we've scrubbed missions and crashed satellites before because of risk of contamination. But I think overall that it will just pique interest enough to try to get us over there.
Sure, how cool would it be to land a human on another planet? We already landed people on the moon, and I feel like
Mhm.
this is like the next major accomplishment, and landing a human on another planet, that'd be such a great achievement, not only for humankind, but for science. And, I think SpaceX has made their intentions known, like, hey, like, this is the future, and like, you guys should jump on board. So I don't know, it sounds cool.
Trying to spark that next space race.
Exactly, like that led to so much technological advancement with, satellites and, rocketry and all that stuff. So, I, correct me if I am wrong here, but like the main thing that's hurting us from getting to Mars is just, getting the rockets to like get there, right? Or is that not the main is that not the main
Um,
thing?
I mean, that's the main thing of getting equipment to Mars. The main thing of getting people to Mars is keeping people alive for that long and in those environments.
And
Um,
also finding the funding and
I
the
think the
planning for
funding
it.
could probably be there. I think it's more of a technological issue than it is a funding issue.
Yeah, we never really set up a, a thing on Mars for actual habitation. Yeah, so that hasn't really.
We have a couple of deserts in the United States. We've got some
Right.
mock Martian habitation set up to kind of experiment and do some research on those future Mars habitation projects. So we're looking into it, but that's a long way away.
Like, it's got no oxygen, right? Or very little.
No, it doesn't have an atmosphere.
Okay, so we're pretty much just walking like just straight, like like straight space. You're just walking on
Yeah,
a
I
rock
mean,
planet.
It has one, but it's real weak
it's just like
to the point where it's
it's almost
dangerous.
negligible.
Yeah.
There's no magnetic field, so you're just getting battered by the sun's rays and the solar wind. So you have radiation risks there. There's no
Yeah.
oxygen, so you'd have to be in a
You'd like
self-contained
have to
environment.
be underground
So like,
if they're going to be there for any amount of time.
Yeah.
so even with like a spacesuit on, like you just couldn't do
Right.
it. You would just
Not for long periods of time. Like you
You
go
have
out
to
and
have
walk around for a bit, but then
Yeah.
if
If you're going to
you're
be there for
exposed,
years, you're going to want like feet of material in between you and the sky.
Oh geez. Okay, so the movie The Martian is not that realistic. Like
I mean, it was actually pretty good. He
Not
wasn't out there
bad.
for that long.
Because they were there for like a couple year trip or something, if I remember right, or less. The one thing that movie got wrong was
The
wind.
wind, yeah.
300-mile-per-hour wind would like not even make you stumble, like because there's no like
Wait,
air.
what do you mean? It wouldn't make you stumble?
So
Wouldn't it blow
wi-
you away?
wind. Think about wind like this. Wind is basically just particles pushing up against you, and so since our atmosphere is so dense,
Mhm.
whenever you have a 10-mile-an-hour wind, you're getting pushed by 100% of our atmosphere. So you're feeling those particles push against your body, and that's what causes the force that you feel whenever it's windy. On Mars, I forget the ratio. It's like a million times thinner air, so you have like a million times less particles pushing at you at the same. So you'd have to have the same exact ratio upscaling for how fast the wind goes in order to feel the same effect.
Okay, so since the air is so thin, 300-mile winds is nothing. It's like a light
Right.
breeze or something.
Yeah.
So in so in the movie, they kind of overplayed the wind.
Oh yeah, I mean it threw
Definitely.
over a rover.
Oh, that's right. Yeah, in like the beginning, like that
Yeah.
tornado.
Yeah.
Okay, so that's super unrealistic. Okay, gotcha. Okay, wow, that's fascinating. So, how far away do you think we are to landing someone, if we ever will, on that planet?
I mean they're projecting like 25 to 35,
Like,
2025 to
okay,
2035. Um, I imagine we might actually have a manned mission head out in the mid 40s.
really? So, like, their projections are off, you think?
I mean, I don't know if I've ever known a mission to launch on time. You know, with
Yeah.
the average being 3 to 5 years delay, and since this one is such a complicated mission, I'm gonna just go ahead and double that.
Right.
Okay.
I think it might be sooner. It depends on what like SpaceX does, because they have like normally you can like add a bunch of years to a prediction, but even if you add a bunch of years to SpaceX's prediction, that's still gonna happen soon. So I don't know what how that's gonna work. I know NASA plans on doing like a space station that orbits the moon before they send people to Mars. So yeah, their plan could be quite a ways off.
So NASA's a bit more slow in their like,
Yeah, they might be
yeah.
more practical though too, because like they're trying to do it right. I don't know.
Mm.
SpaceX just kind of want, or according to them, they just kind of want to get there. So
Yeah, NASA's pretty much drowning in policy right now. So their processes always take a whole lot longer than someone like a private company would.
yeah, and the problem with NASA's Mars plans for the past like what 60 years, they've always had a Mars plan that's like 20 years out, and it's always been like 20 years out, like
Like
for
20 years
60
ago, it
years.
was
So
20 years out. Yeah.
yeah,
Okay.
so yeah, I'm always pretty skeptical about those plans that they put out, but
Gosh. What happened to NASA? I feel like they were like the juggernaut, like way back in the day, and now they're just like
Every
nothing.
year, it's just policy. I mean, they still have the brains to do all this stuff, and they still are putting out amazing things.
Mm.
It just every year the policy gets a little bit more. Like every accident that happens, it compounds that same issue. You got to be more careful. You got to do all these tests.
Yeah.
And like back in the day, we could just like the amount of accidents that happened. We were just had to beat the Russians. There was such a intense race. We had to do what it took to get up there, and now
it was like a military race. So
people understood what they were doing. They were like, hey, well, we might die, but we're gonna be doing this. And now there's an understanding that I don't want to die. I'm not expecting to die. I expect this to be a safe mission.
Yeah.
And instead of like understanding the risks,
Yeah.
we're trying to get to the point where, and it's good and bad. It shouldn't be a 50-50 chance. It should be a 99% chance of success. And trying to meet those numbers gets you drowning in policy, so it takes a lot longer.
I think it's more like we were definitely militarily motivated in the space race, and that just pushed everything through so much faster. Now that's not really a thing.
I don't know
really
if
have
you know
that
much about the
motivation.
military, but they don't get things done very quickly.
No, I thought they're always like the first ones to like create new technology, and then like the general public catches up like 10 years later.
I mean,
'Cause-
just like with the Soviet Union, like there was a lot more
Okay.
motivation, is what I'm saying.
Yeah, I wouldn't say militarily motivated. I would just say that there was a space race between two countries.
Right.
Two super powerful countries at the time that
Mhm.
you know
And
wanted
China's planning on going to Mars sometime, not too far out. So that might
like
motivate people more.
like China, like the government, or like Chinese corporations, because
The
like
the government.
oh, like the government. Okay, because I know the U.S. is kind of taking a back seat in terms of like space races and stuff nowadays. I feel like that's the main problem with NASA now. It's like the government just doesn't have the motivation to do it anymore.
Yeah. They pay SpaceX. Like that's how SpaceX gets a lot of their money to do stuff. So
Yeah, we've revamped our model to a more corporate competitiveness model.
Which is the American way.
Yep.
No, I'm completely fine with that. Yeah. So like our competitiveness has been kind of off, handed off to our companies as opposed to, NASA. Like each aspect has its own role, and it works out well together because NASA, is super reliable and it's going to be putting out product, but they might take a little bit and they be doing things a little bit different. And we just basically have multiple strategies that we're employing at the same time.
Yeah, I mean, I think the future is going to be how the economy pushes it. With this new and not invention, but this new discovery of reusable rocketry, I think is going to make huge possibilities with space. Is that not the thing? I mean, I feel like they've been talking that up for years, and and now it's possible, and you could reuse
Yeah,
this rocket and stuff, which is cool.
yeah, economics drives everything, and with the proof of concept that SpaceX has delivered, he's been just getting swamped with contracts,
Yeah.
and just proof that if you can make this stuff cheaper, the industry is gonna boom like it is doing right now.
Is SpaceX close to being profitable?
Well, let's see.
It depends on your definition of the word profitable.
Once they got all these
They-
reusable rockets, they'll stop having to
they make money.
right.
Well, I know his other company, Tesla, does not make money. They're drowning in
Right.
debt. I don't think the company's been profitable since it started. Let's see. Well, how profitable is SpaceX? I don't know. But anyway, so I think from what I was reading from the future is satellite technology, which I think, Danny, you're kind of an expert in. I've been reading about the possible future of broadband satellite internet, and that it's going to greatly reduce the cost of data, which in our world is like king now. Like the data you use on your cell phone plan, the data you use on the internet, the data you use to drive your cars now. I mean, these autonomous cars, they need satellite help. So, would you agree that like the more immediate future is investing in satellite technology?
Yeah, talk about satellite constellations.
I mean,
Yes.
as far as immediate future, I think you mean present.
Yeah, like in the next 5 years.
I mean, next 5 years, I think maybe in the next 2 years is kind of where that's going to end.
What's gonna end? What do you mean?
Just like, so just an overall explanation. It's booming right now, and we're putting stuff up on a weekly, if not daily basis. Stuff is constantly getting launched into orbit. If you just look at like launch schedules of the planet, the calendar's full. All these countries are getting into it. Countries that don't normally have a constellation are putting things up there. The countries that do have stuff up there, they're continuing to launch and ramping up their production. Everyone wants a GPS constellation. Everybody wants broadband. Everybody wants TV, internet, communications, research, and it's getting extremely congested. But there's a benefit of microsats, CubeSats, microbotics, and so one satellite will go up or one rocket will go up, and a payload might have hundreds of little tiny satellites that it just like launches out in one go. And so the industry is booming, and especially with companies like SpaceX offering cheaper launch. So all these small companies now can launch their satellites that they've been developing, and the industry is booming right now. And with that comes good things and bad things. Like, have you ever seen the congestion map of satellites? If you pull up the map that shows congestion of satellites, the Earth is dirty, and it is going to be a huge problem, probably the biggest problem to affect space and the biggest hurdle of future space missions. is not going to be our technology. It's not going to be like how strong our rockets are. If we keep our people up, it's can we avoid our own constellations? Can we avoid all the space junk?
Yeah, like I've heard like the space junk is a huge issue that like it could prevent us from launching in the future because there's just massive like things in orbit that are traveling thousands of miles an hour.
Yeah, not even massive things. Things the size of baseballs going tens of thousands of miles an hour, just punching through your hull. Could end your mission right there.
That's crazy. So that's probably what might prevent us. Like, is there like a a solution to fixing this?
There's a lot of companies working on it. They've tried a lot of things as far as space cleanup. There's nets, there's hooks, there's gummy balls, there's magnetics. I don't know. People are trying out a whole lot of different things. There's a couple tests. I'm not sure if it happened yet or not, where you shoot a net and try to capture a piece of space junk, and then that net has tiny rockets on it, and then those, like I'm talking about, little like ion rockets that just enough to spurt that piece of space junk into the atmosphere and have it burn up.
Yes.
So kind of like pushing it back down into Earth so it like
Yeah.
burns
To
up.
deorbit them, basically.
That could be an industry in and of itself.
Yeah. SpaceX is even thinking about that. Their newest Falcon Heavy, they like postulated might have the capability, but that would probably be with a lot of augmentation. I don't really know how they do that.
Mm-hmm.
I guess just the main fairing part, where they normally were thinking about having a passengers or payload, they could turn that into like just a giant bay door that grabs stuff.
Just grab
Like,
stuff.
Most of the junk is not too big, is it? Like there's a lot of smaller stuff, right?
Oh yeah, there's tons and tons of smaller stuff. I'm trying to find the recent statistics.
Yeah.
Large majority of it caused by China's ASAT test. Yeah, whenever China tested out a kinetic kill weapon on a satellite, it blew up in space and sent thousands of particles of little debris all over our planes of orbit, and caused a lot of issues.
Yeah,
We have to track every little piece that they had blown up in their satellite for their test.
Gosh. Man, so there's a lot of risks, that we
That's crazy they
haven't
did
foreseen.
that. I'd imagine like Russia and America would never even consider doing that.
Right.
I don't even know what they were
It's just
thinking.
3 different personalities of 3 different planets. I mean,
Yeah.
there's just imagine like 20,000 little particles of. I mean, space is big, granted, but that's a lot of things flying around out there.
For sure. So commercially, we're doing all of these things for science and for help, but like, is there a commercial or tourism in industry? Visit the space station for a week or land on our moon colony. Like, how realistic are these things that I've been reading about?
There's already been tourists go to the space station that dropped millions of dollars to do it.
Yeah, I mean it's
so,
if not
for the rich,
same level, it's approaching the same level as research and science and development.
And there's pretty much all the other private companies other than SpaceX, they're largely focusing on space tourism, or at least a decent portion of them. Like
I mean, if we're just talking
Amazon
about rocketry, then yes.
Yeah, like that Jeff Bezos with Blue Origin.
Mm-hmm.
That's kind of what they're angling for at first.
Yeah, I mean, Blue Origin and Virgin Galactic are both.
Yeah. Shoot people up into low Earth orbit, or shoot rich people up there. Let them look through a window.
Yeah, Virgin Galactic was it $250,000 for to experience 0G on their little space hopper.
Yeah.
How long would you be up there? Did they say?
I don't know the recent estimates. A minute.
Yeah, I think somewhere under 5 minutes somewhere.
250K for a minute.
Dude,
Hey,
that's like a drop in the bucket for people.
Yeah, if you get to
Some,
go to space,
but like, wouldn't you have to like
and you got money.
pass like some physical requirements? Like, you can't just send like anyone up there, right?
No, I
Uh,
mean, it's all you have a couple little tests you have to
yeah.
make, but I mean, there's been some questionable people up there, but yeah, I mean, as long as you can show that you're not gonna die.
Yeah, if you're not gonna have a heart attack right when
Yeah.
the launch is happening, they probably wouldn't want that publicity.
Seriously, dang.
So
Gosh, I just think about like the future of this all the time because eventually, like, that's where we have to go. Like, there's only two frontiers left. There's like space, and then there's like the bottom of the ocean.
yeah,
Like, which
But-
one is more? Do we feel like will benefit us more if we explore it?
there's a couple kind of future civilizations. One of them is it's spacefaring. The other is like master the planet stuff. So if
Yeah,
you
I
can
mean,
use all the energy available on Earth, like that's like just from the sun right there. Like that's ridiculous. But you'd have to do some crazy, get some terraforming technology going on to stop problems. So
and there's a
it's-
couple of different philosophies among big name people. Like Bill Gates, his focus is more on like let's make this Earth as the best Earth that we can be, and before we send off into space, let's just focus on what we got going on here. And then other people are like, oh well, let's just try to get out there to make sure the humanity exists.
It's like this is a burning building. Let's get out of here.
And it's
Make sure we
important to
have
do
a
both.
future.
Yeah.
That's crazy. So I saw a movie on Netflix. It was new. It was called Titan, I think. And it goes into a really interesting concept. But basically, the world's dying, or it's being destroyed by nuclear winter or whatever it was. I forget. But NASA was developing like genetic enhancements on certain individuals, so at least some form of the human race could survive on another planet. And the planet that they were, well, it wasn't a planet. It was the Jupiter's moon, Titan. They were going to send a group of them there with genetic enhancements so that the human race could survive beyond Earth. It was really cool, but they pretty much just genetically enhanced this guy where he wasn't even human. He could swim, he could hold his breath for like an hour, he could swim, he had like these they pretty much like made him a different species, and like I feel like if we're gonna like us in our current state can't like just live on another planet without a severe, just technological either like advancements or modifying the like existing planet, or we can modify ourselves. So I don't know.
Yeah, that's a cool. That's one of the ways to inhabit a planet. There's a couple. Like one is modify your body so you can walk around outside on Mars regardless of the low atmosphere and the radiation. Another is to build structures and just be ourselves normally. There's and then another is just to terraform the whole planet. So right now we can do the structure thing maybe, but the others are
Yeah, I mean,
Sure.
out of
we could
reach.
definitely do the structure thing. We know. I mean, it's just
Yeah,
intensive thing.
just
Biology
space station on
wise,
ground.
that's gonna be so far into the future. Like radiation just breaks down organic material. That's why it just destroys it. So
The best thing we can hope for is material technology, probably.
oh yeah, material technology and terraforming technology.
Yeah.
So what
And-
would it take to? So Mars itself is probably where like we're gonna try and go, and like, but like, how can we terraform or make the planet livable? Like, is that even possible?
There's one thing, an idea that would work, that if you put a spaceship in between Mars and the sun, there's a point at which you can don't have to have too large of a craft to be able to throw up a shield for the radiation, actually.
For like this,
Or it can stay in between like the encampment and the sun and just block that radiation straight up. So that could be a way to deal with that.
I hadn't heard about that.
Interesting
That's
idea.
some crazy shield.
How big does
Yeah.
it have to be?
The way, well,
Just has to be a couple inches thick if it's lead.
let me
No,
just.
like,
Oh
wide.
God! All right, yeah. So let me talk about radiation shielding real quick. Right now, the way we do it is we have a device the size of a planet rotating liquid iron that is just in the core of our planet, generating a magnetosphere that surrounds our Earth. To be able to create that artificially sounds insane.
No, but like a straight up wall does stop radiation.
Yeah, but how is it going to get its heat from the sun
I
then?
would say, like, how would we get like the
I mean,
heat
it's
or like
not
the
gonna like
energy from the sun to get to Mars if you're just blocking with this giant wall?
it would be like
The
a
Trump space
pinpoint
wall.
on in the sun. It wouldn't be like a huge wall blocking the sight of sun from people. It'd just be like stopping the main hardcore direct beams of it. I don't know. I definitely have to look into it more. It might not be too viable, but
That sounds
that's just an idea I've seen.
incredibly ambitious.
There's crazy stuff like that that could work. Like,
So kind of like sunglasses, but like
yeah,
covering
sort
the
of.
planet. I don't know, man. That seems the most unrealistic thing I've ever heard.
I'd have to look it up again. It's been a bit since I looked at that.
So, Danny, you were saying that like the Earth has a magnetic field that blocks solar wind, which is the reason that we can like live on this planet, and that's because of
Right.
our like molten core, like, and the iron that's in there. Like, what's Mars's core like?
I mean, their core used to be just like ours, but
Oh,
and if you do look at some of the magnetic studies on the planets, theirs is basically dead. There's a few magnetic anomalies around. Their planet acts kind of erratically. So ours is kind of a uniform shielding. You know, with North and South Pole, it's bipolar. And as that goes through the years, you know, like it flips all the time, north to south, south to north, flips back and forth. And during those flips, you have like crazy data. So it might be in some type of weird flipping phase, but most likely it just has a dead core where their core has gone cold and it's stopped. It's no longer molten and it's more just solid. But you need that molten core and you need it to be, you know, have the rotation to create a magnetic field like that. And that's why, you know, there's ideas of just bombarding the planet with nukes or asteroids to heat up the planet again and to kind of jumpstart the magnetic field.
Speaking of magnetic fields, that shield I was telling you about, apparently the idea is to like have a miniature magnetic like magnetosphere, not like a shield wall, but like a magnetosphere to stop the radiation, and the trail behind it, Mars would be within that trail of protected area.
An artificial magnetic field?
Yeah, so
that makes way more sense than
a wall.
Than a leaden wall.
I just forgot what the idea was. Yeah, this does make a lot more sense.
Yeah, and you would just create like an artificial like spinning iron, you know, just like the core, an artificial core basically at like a Lagrange point in front of Mars to, you know, just create if you look at the graphic, it kind of just creates a shield.
Can you
reduce solar wind stripping?
It's in the podcast.
To establish new, so like this could help Mars actually build up an atmosphere over time, and actually maybe get established a little bit with like the air would become just thicker over time. Maybe I know that the core of Mars isn't really very good for that.
That's actually really cool. I hadn't thought about an artificial core or magnetic shield. So most of the reason why Mars doesn't have an atmosphere, the idea is that it had an atmosphere, but the solar wind that was bombarding it strips away the atmosphere, and so there's no barrier in between the Earth's surface and space without an atmosphere. And if the solar wind just bombards that and hits those particles that are on the planet's surface and strips them away into space. And the longer that goes on, the more particles are stripped away. So with a magnetic field blocking the solar wind, the planet is able to hold on to its atmosphere. And so you could create an atmosphere on Mars if it has a significant shield.
Yeah, and just put a bunch of factories on there.
Yeah,
Global
factories.
warming it. That's basically terraforming.
Oh yeah, a lot of the terraforming ideas is just to like throw algae all over the place,
Okay, so
Really?
let them breathe. Yeah.
Oh yeah, I
because
guess
you need carbon
organic.
dioxide, right, to create.
It'll
Yeah.
spread. Yeah.
Mhm.
Yeah. Oh man.
We're gonna. That's gonna be a while. Like we'd have to be 100% certain there isn't any life there before we did that.
Or we
Or
could just
China
who
will
cares?
just say,
Some
"Screw it, throw some
Some
algae
people
on
doesn't
it."
really care, like
Yeah. And if one guy throws a bunch of organic stuff on there, like
it's too late.
done.
Might as well
Yep.
just get going.
Yep.
Okay, so you basically put a magnet iron ball and like spin it in front of Mars, and it just like, if I'm looking at this graphic right, it just kind of like pushes the solar winds like out, and if Mars is like directly behind it, it won't hit it. They'll just go around it,
Yeah,
or am I
that
seeing that
point is
wrong?
called a Lagrange point, which means it stays static relative to Mars,
Okay.
and it can stay just in between the sun and Mars and just do that. And I don't know what it'd be made out of. It says there's new research into miniature magnetospheres. I don't know how they do that, but
It's just the same way you create any type of magnetic field. Just rotation and metal. It just without getting too much into the science, just
Sure.
that's how a magnetic field is created. We do it all the time on a small scale, so that's just a huge scale project.
Gosh.
whoa, there'd be an increase. Yeah, if they had this, they're estimating how it would affect it, and it's interesting. Like increase in temperature by 4 Celsius, and which would be enough to melt the carbon dioxide ice, and would trigger a greenhouse effect, warming the atmosphere further and causing the water ice and polar caps to melt. And they estimate that it could lead to 1/7 of Mars' oceans being restored. So that's just doing that would have massive effects.
That is the single most important thing for a planet, in my opinion, is to have that magnetic field. Well, in being far, in the Goldilocks zone.
Is Mars technically in the Goldilocks?
It's on the very edge of it.
Yeah.
The very outer edge.
Gotcha.
So it's possible, is what you're saying.
Oh yeah.
Okay.
I mean, it was probably already happened, because
Yeah.
it had liquid water and an atmosphere.
Is it moving
fast.
away from that zone, or is it staying the
No.
same? Or, no.
No.
Okay.
It's so slow if it is moving in a direction that it doesn't matter.
If anything, it's moving towards the sun. So
So I feel like
but that's irrelevant.
That's our solution. How long would that take?
How long does it take to build a giant magnetic?
Yeah, like
imitant,
well, no, like theoretically, if we created this.
All right, yeah. Let's say that someone created that, and he had been working on it for forever, and he's like, "Oh yeah, look what I have." And then we also have the rocket to deliver that there.
Well, yeah, this is NASA is doing this or has done all this research. So if they think it's
and
smart,
then
they could
so
push
we're
it.
able to get it there. How long would it take the planet to become livable?
Correct. Yes. Like, how long would it take to like do this? Like millions of years, thousands of years, hundreds of years, 1 week.
Couple days.
Oh yeah, come back in 2 months, and you'll be.
I would say
we'll have vacation homes and stuff.
To the point of livability, I don't know, 100 years.
Really?
'Cause, I mean, it's instantly going to be blocking the worst of the sun. So already you have a planet that is shielded from the sun.
Yeah. This. Yeah. From
for
this,
everything to melt.
Oh yeah, go ahead.
Oh yeah, so for everything to melt, ice ages can get kicked off in hundreds to a thousands years. But I mean, if we speed it along with other stuff and put factories out there, put algae out there, you can see it in a few generations probably to make livable. Very, very, very harsh. But possibly livable.
You could
I mean, it's still going to be cold. It's still going to have like not a Earth-like atmosphere, but you'll be able to walk around on the planet without fear of, dying right away.
Without like a suit, like it would
No,
just be really
you'll have to have a
cold.
suit.
Oh, you will have to have a suit. Okay.
Yeah, until you get the atmosphere perfect, which will take
millions of years.
probably 500 years at least.
500 years. Oh, okay. Dang, this is so fascinating.
I don't know. You have to seed an entire planet with a new atmosphere. So
this is saying it would have benefits pretty soon, though.
Oh yeah, you'd see
Obviously,
results
because the
quickly,
radiation protection, it would allow us to do all kinds of stuff on the surface of Mars without worrying too much about the radiation, basically. And like the just water of it, the water would it would heat up maybe pretty quickly. So you would see that effect with the
there's
melting,
water
maybe.
there.
Yes?
There's water there, it's just frozen, right? It's just
Yeah,
okay.
quite a bit.
Quite a bit of water. Okay.
So that's good, and that's how you would make. All you need is water to make rocket fuel.
Really?
Like if there's water there, you can make rocket fuel out of it, which is pretty nice. And
Okay.
that's what I think SpaceX plans on doing. The first things what they get there, they want to be fuel production because they're trying to make like an infrastructure for traveling to and from.
Mm-hmm. Gosh. So what's all right? So there's this magnetic shield blocker thing that you just described. What's the other way? Is there another way that's possible that could be more?
One, I'll do the underground one.
Okay.
There's the best idea with that is probably there are like sheer cliff faces, and the easiest way to get lots of dirt in between you and the sun is to drill sideways into one of those, and then you're good. Or you can build a structure and cover it in dirt, which I guess would work as well. That's one strategy.
Yeah, dirt and Earth. Well, I guess would it still be called Earth?
I don't know.
It'd be-
Mars?
it'd be- We'll just call it rock and dirt.
Yeah, rock and dirt is a fantastic insulator from space weather.
So we could live underground, kind of like they did in the Matrix. You know, when the machines took over the surface, we were living they were
Exactly
living
like
down.
that.
Okay. Or you said we could heat up the planet in another way.
Just launch a. I hope that they're not still considering it, but the primary idea for a long time was just to launch a ton of nukes at it. Just bombard it with nukes.
Just make it so hot and that make it spin that it would just create a magnetic field.
I don't even know what that. It would cause a winter.
It just cause the core to warm up again. Because right now they think it's
Wait,
cold
what?
and
That would affect the core. I thought it was more of an atmosphere thing when they were talking about nuking it. I didn't think that would affect the core.
they wanted to put like all of our nukes there.
I mean, well, we're not using them now, so
Yeah.
I
Yeah,
mean,
that's true.
that could be.
I mean, it's a good idea and a bad idea because like one, it would warm the planet up and it might give it a magnetic. It might just jumpstart
Yeah,
it. Who knows?
it would cause more of an atmosphere because of the greenhouse effect from nuclear winter is a thing. Maybe I don't even know.
But if you don't block those,
I mean, there'd be
those
radiation
solar
particles
winds-
everywhere, and you'd have to wait for it.
Yeah, but like,
Yeah.
weren't you saying like even if you had
Yeah,
an
the
atmosphere?
whole idea is to give it a magnetic field.
Okay, gotcha. Because so like creating an atmosphere is not what we need to do. We need to create the magnetic.
Yeah, because if you
field.
just went there and like if you
Yeah.
could snap your fingers and create an atmosphere, it would just get stripped away again because there's no
Right.
magnetic field protecting it.
That's crazy. So this isn't as outlandish as people think, or is it still like?
It's
Depends on
It's
how
crazy.
viable making a
It's
micro magnetosphere is. I don't know. We don't really have. We've never really done that technology yet. So
I mean, yeah, they're all theoretically possible.
yeah.
Your pad and paper write down, you could see that it would happen, but like trying to get everything there, trying to develop these things, put them in the right place,
Yeah, that's
unrealistic that we see it. I mean, that's not going to happen in our lifetime.
Do you think now this is more of an opinion thing? Do you guys think that is our future, is space, or can we just master the planet so much, or are we just killing it by?
No, we're gonna do both.
We're gonna do both. Okay.
Yeah, I mean, we're gonna wreak absolute havoc on this planet, and then we'll bounce back in 200 years or so. I mean, we're gonna be missing tens of thousands of species that we've killed off, and most of our land surface is gonna be eradicated, and there's gonna be no natural resources left. And it might be, you know, some wars after we run out of resources, but eventually we'll learn.
Yeah,
And by that time,
I'm worried
hopefully,
about.
we're also pretty, you know, at least started on some of our space colonies, you know, the Moon and Mars.
just worried about the current state of Earth, and if like funding for space might cut down a bunch if there's a bunch of problems with global water shortages causing more war
Crisis
and just
crisis and war is a great motivator for science.
yeah, maybe not for space though, but maybe like for space exploration because that's like kind of
like practical space science will probably be fine. Research-based space science, no, that's probably will get cut off. Like we're not going to care about whether a plant grows differently or like developing better toilets or something. It's gonna be like, how the hell do we get off this planet?
Yeah.
The biggest thing is just the cost going down with the reusable rockets. For example, like a SpaceX rocket that can launch astronauts up. Well, not yet, but they're going to get approved for that eventually. Is a 61 million thereabout, and right now NASA pays 81 million per person to ride the Soyuz to the space station.
Good lord. So we need the cost to come down to make
that will help
mass space travel possible.
Yeah.
Right. Yeah. You can, if you even go to SpaceX website, it's almost set up like a rental service. Like they show their rockets that they have available for you. They show like the modifications they can make, like the extra boosters they could put on it. And then they should show you the price point. If you want to use this rocket, it costs this much. You want to use this rocket, it costs this much. And way cheaper than paying Russia to send our astronauts up. That isn't even just the cost of launching. That's just the cost that we pay them so our astronauts can ride on their rocket.
Right.
So I'm looking at some numbers here. I don't know how accurate these are, and you guys can, correct me here. But since the launch of reusable rockets, the cost to launch a rocket was 200 million per use. Now that since the advent of reusable rockets, that's gone down to 60 million. And with advances in the technology, it could potentially fall as low as 5 million a launch, which from 200 million to 5 is incredible.
Yeah, if you think about it, every time you reuse it, you're like having the cost basically because you get another launch out of it. So they plan on reusing these rockets like more than 20 times for sure. Mm-hmm. Like 100, like the same amount they do like a Boeing 747. That's their ideal goal.
So right now we're mostly just launching satellites into space. That SpaceX is right, or is that, or are they launching?
That's
other
their
stuff,
biggest customers because everyone wants to launch those. They do stuff for NASA just because NASA likes the.
Yeah, they have contracts with NASA. They have contracts with Air Force. They have contracts with other companies in other countries.
Okay, how much does it cost to make a satellite? Like, say I have a company or I'm NASA and I want to launch a GPS satellite. Like, how much does it cost to make roughly? I guess.
What was the one that blew up recently that was like had been being built for so long? It was like, was it something to do with Facebook or something? What was that?
I don't know. I didn't hear it. I didn't know.
I don't know. I don't think it was Facebook. It was some
satellites. Why
some
would they want
large
satellites?
company that was sending one up, like 1 point something billion dollar satellite, and it just blew up.
Was it the shady one, or are you talking about?
Oh, no, it was something else. Here, yeah, it was a SpaceX rocket. Oh no, it was a $200 million satellite. Jeez. And it was, a Facebook thing.
Facebook wanted a satellite. Oh, geez.
It was
we're fucked.
It promised to extend social media network reach across Africa.
Okay, gotcha.
Satellites are, like I mentioned at the beginning of this, they vary a lot. A GPS satellite, like you mentioned, is one of the more advanced satellites. I mean, you have stuff like James Webb Telescope and those type of satellites are about the highest end that's the highest end satellite. The James Webb is the highest end thing you could do, along with the ISS. Those are still technically satellites, but the ISS is we call a space station.
Sure.
And then you have CubeSats, that cheap. You could probably do that for around $100,000 or something, even less. And it's just a tiny little satellite, probably the size of your computer, that you just throw up, and it just sends basic data or forms a network or whatever they really wanted to do.
Gotcha.
The satellites that most people think about, things like communication satellites, GPS satellites,
Yeah.
they're more around like 500 million or so. Like
500 million.
Yeah.
Okay.
yeah, like the modern GPS that we're working on to kind of replace our current constellation and buff it up a little bit. They're about 500 to 600,000, or 500 to 600 million per satellite.
What could bring the cost of that down? Just demand or mass production, or like what could we do to make those
Cube
cheaper?
satellites. That technology improves.
Yeah, I mean, as the technology gets better, as manufacturing gets more extensive, we get more. I mean, these things need very precise parts. They need to be tested in very specific situations, and they have to be. There's a lot of tests that have to go under a satellite to make sure it's going to survive in space. Space is really harsh, so you have to make sure there's no like cold welding is an issue. That's in space. Like if you have two metals of the same type that touch each other, they just weld together. So if you have a part that slides over another part, and you can weld up, and it could stop your satellite from having that movable part. Make sure your gyroscopes are going to be able to move, so you can rotate your satellite. Make sure that there's no like chemicals. If there's any type of like atmospheric chemicals or chemicals of any type in a material on your satellite, and it goes into space, there's going to be outgassing. I mean, it's just a very technical process, and it's
if you launch
expensive.
a satellite into low Earth orbit, how long until it deorbits naturally, unless you like have thrusters on it of some kind?
Naturally,
Yeah.
a handful of years, depending on where at. And I mean, if you go,
So yeah, a lot of them have like little thrusters, don't they, to
Mhm.
extend their lifespan?
Most of them.
And
It's not
nowadays
all.
there's ion thrusters, which all you need are solar panels, and you can get a
Yeah,
little
just
bit
like
of thrust.
little. They call it mouse farts.
Do they?
It's just sending a couple ions out, and, like basically like shining a flashlight almost and it just enough, like a mouse fart, just
Right.
enough to give it a little bit of a boost.
Keep it where it is, pretty much.
Yeah.
Oh man. So the future of space is bright, you would say.
Yeah, it's both. I mean, there's a lot of really awesome plans coming up. I would love to see the James Webb up there. That's
for
that's
those of you who don't
basically
know, that's like the new. It's like the replacement for the Hubble, right? Pretty much.
it's more than that.
It's more than that. Okay.
It basically we were blind before, and we are given eyes now. We will see everything. It's I don't know. I definitely recommend looking into all of its capabilities, and I think it got pushed back again recently. So hopefully 2020 May. I think 2020 is the most recent launch date I saw for that.
Here, look in the chat, Jared, at the comparison.
Okay.
Like the things it does is just.
Okay, let's see here. Hubble mirror and
That's the
James
size
Webb.
of.
Oh wow! So it's a lot bigger, pretty much.
It can
It's
see
just-
further, which means it can see further back in time, basically. So they're trying to see to where the universe like started, look like that far.
So could we see how big the universe actually is instead of? Well, I mean that's
a complicated question.
Yes, that's
that's more than a technological question.
Sure, but this could help us see a lot more in the universe, pretty much, like a lot more.
Yeah,
we can see like
change
so many things.
Most of everything that we know, I think.
Like the
And
birthplace
we can
of. I don't even know.
Oh, that could be another.
The early universe.
That could be another topic for another day. But
yeah, one thing that has really fueled most of science of what we know is optics. If you think about it, we didn't know anything about stars. We invented a telescope. Oh, all of a sudden we know more about stars. We invented more telescope. We know more about physics and space and relativity. And then go on the microscopic level. We didn't know anything that germs existed. We invented microscopes. Oh, there's germ theory. We're made of cells were made of smaller parts of the human. Oh, there's diseases and viruses and bacteria. Oh, actually, we even have genes and we can modify genes. It's all, everything in science is basically fueled by the ability to see.
Yeah.
And the better ability we have to see, the better our science and the better our capabilities are going to be. And this is going to be the best thing we have on a macroscopic level to be able to see. And so I expect a lot of great things to come from it if it happens.
What do you mean if it happens? Is it not going to happen?
Just, you always got to be questionable. It's a
Sure.
extremely precise thing, and being able to finish it on time and then
It has to
launching it.
unfold
It's got to
in
launch.
space.
You got to put it
Yeah, you got to put it in
like
space.
on the
first.
nose of a bomb that we are sending into space. Like, there's a lot of things that could go wrong.
Controlled explosions to get it into space.
But
Prolonged
Wow.
controlled explosions. Yeah.
Well, I think we'll find out a lot more here in the next even 5-10 years what our capabilities are and what the future of space is. But you guys were coming up on an hour. Yes, flew by. Jeez. Okay. But so basically the future is bright. And with this new James Webb thing, I guess we are blind, and now we will see. And we'll see what the future of space and humankind is. So is there anything else you guys want to bring up before we sign out of here?
I think you wrapped it up well.
Yeah.
Awesome. All right. Well, guys, thank you for tuning in, watching in. If you've got comments on space or the future and what you think is happening, just leave that in the comments, or leave a like or something like that. But guys, until next time, this has been another episode of Trivial